let me start out with, what do I know if they already are congruent? So I have two polygons up there, A, B, C, D, W, X, Y, Z. And everyone see the given here? I'm telling you that they are congruent to each other. So now where do I proceed from there? Why is that so special that they're congruent? Here is why. Everyone right now, visually, put polygon ABCD right on top of WXYZ. All right, put it right on top. You see the sides that match up? Do you see the angles that match up? They're congruent to each other. All right, the sides that match up and the angles that match up, we refer to as corresponding parts. All right, corresponding parts. Don't get that confused with parallel lines and corresponding angles. Separate topic. But does everybody see the sides that match up and the angles that match up? They're congruent because they're called corresponding parts. So I need 8 people right now, maybe the different people, the same people. Give me a pair of sides that correspond right now. So you visually put them right on top of each other. Give me one pair of sides that will match up with each other. 10, one pair of sides. CD and these two? Okay, let's regroup here. CB and XW. Okay, I agree with those. Yes. Those do correspond with each other. Now, because the polygons are congruent, so are these corresponding parts. They are now congruent. Give me another pair of sides that match up, that correspond with each other. You're up, 12. DC, XY, I like it. So they are now congruent, as long as the polygons are congruent. Give me a third pair of corresponding sides. You're up, 13. Yep. And the fourth and final pair of sides that correspond and now are congruent. 12, going right down. DA and YZ, good. Nice job, everybody. All right, well, we said sides, but also the angles are also corresponding and are congruent. So give me a pair of angles now that are both corresponding and would be congruent in this case. Here you go, 15, up. Yes. Another pair of angles. 15 again, let's keep it trucking. B and W. 2 more. 3. Yes. And finally, the final pair of corresponding angles. 10. Angle D congruent to angle Y. Okay. So if 2 polygons are congruent, their corresponding parts are also congruent. Now, I have a little secret to reveal. As everybody was telling me those sides and those angles, I never once looked at the diagram to see if you were correct. And I didn't memorize it before you came in either. There was something else I used. You guys were correct or not. Did not even look at the diagram as you told me those sides and angles. There's something else I looked at to see if you guys had the correct sides matched up and the correct angles. I looked at that right there, which is called a congruent statement. It's called you're going to have to write your own by the end of class today, a congruent statement. Now, how did I use that to know you guys were correct? How did I use that every single time to see if you guys matched them up correctly? Well, ready? CB. Here's the first one somebody gave. Who gave me this one? CB. Okay, here's what Naomi gave me. CB. So all I did when she said CB, I looked at quadrilateral ABCD. Where's C and B? Second and third letter, correct? And then she said, oh, congruent to XW. Where's XW in the other quadrilateral? Second and third. All right. Who gave me C congruent to X? Who gave me C congruent? Okay. When Jenna gave me this one, I said, oh, where's angle C? In the third spot. So it should match up with the letter in the third spot in the second one, which is X. All right. This will always be written in a specific order. All right. The order here matters because the sides and angles will always match up given the congruent statement. Does everyone see the trick? Not the trick I use, but what I use to see if you guys are right or wrong. We see that now. All right, because you're going to have to write your own in the correct order here in a second. So bottom line before I move on, if two polygons are congruent, so are their corresponding parts. But now, hey, what makes them congruent? Other than me giving it to you. What makes them congruent? And that's that first theorem I'm going to put downstairs here in your theorem spot. All right. What makes two polygons congruent? You tell me. What do I need to have to make two polygons congruent? All what? All the corresponding sides and angles need to be congruent. All right. So if all corresponding angles and sides are congruent, the polygons are congruent. You have to have everything. Everything. If you're missing a pair of angles, no good. No good. You have to have everything congruent. Sides and angles. Yes, so let's dive right in here, kids. Let's dive right in. Love this portion of the unit now that we're getting into. Are these triangles congruent? Well, how are we going to figure out if they are or not? Ready? How many angles in a triangle? 3. You better prove all 3 pair congruent then. And how many sides? You better prove all 3 pair congruent then. That's what's going to make these two triangles congruent. All those things. All 3 pairs of angles, all 3 pairs of sides. So let's get marked our givens on the diagram. Angle B and D are right angles. Beautiful. Oh, look at all these sides that are congruent. AB is congruent to ED, BC congruent to CD, and AC is congruent to CE. All right, let's get them congruent. Well, first of all, what do we already know about the sides? All 3 pairs of sides, that's done. Now we got to work on the angles because have we written down any pairs of angles congruent yet? No, all we wrote down were B and D are right angles. We never said they were congruent. So you guys are on the hook for all 3 pairs of angles right now. Give me a pair and why they're congruent. All right, before I can say the triangles are congruent. So somebody start out with any of the 3 pairs of angles. Let me know what pair you're going to pick and why they're congruent. 22. Which ones again, Bill? Got it. Yep, you are 100% correct. Angle ACB is congruent to angle ECD. I wonder if any of your classmates know why. I hope so. This is something we've talked about a ton. Those 2 right there. Oh boy, I could see puzzled looks on people's faces. Come on. This is easy points right here. You're better than this. 4. Thank you. They're vertical. Yes, hi. Welcome back to vertical angles. Yes, vertical angles are congruent. Please don't put angle C congruent to angle C. No, no. Name it with 3 letters. All right. It's not angle C congruent to angle C. 1 pair down. Where's another pair? 14. Another pair up here? Yes. B and D are also congruent. Something we've also talked about. Look at the symbols you put there. Why are B and D also congruent? 5. What did I put at B and D? Okay, what? Done. Two down, 1 to go. What's that 1 pair we have left? Got to prove why A and E are congruent. A and E. And if you have a thought why they're congruent, forget it. If you have a thought why they're congruent, forget it. This is going to be a new theorem, yes. Well, some of you may know why. You can explain it in words, but it's nothing we have talked about, has been up on the board, nothing. How many degrees in this triangle? How many in this triangle? I got 2 pair congruent. What's got to be true about the 3rd pair? They have to be congruent if they're all going to add to 180. And isn't that what I have in this proof already? I have 2 pairs of congruent angles. Okay, so go back to your, flip it, go back to your theorem. This is the 2nd theorem and final one of the day here. In 2 triangles, if 2 pairs of angles are congruent, what can you tell me? The 3rd pair are congruent. So for step 4, that is how we're going to get angle A congruent to angle E. Now, you can be honest with me. Some of you are a little bitter right now that you have to write all that in your reasons column and remember it every single time I need to use it. All right. Oh, I have to write in 2 triangles if 2 pairs of angles are congruent, the 3rd pair are congruent. That's so much. Even I'm an honors level student. I don't deserve to do that. You don't have to. You can write its actual name of this theorem in there. The name of this theorem, it's pretty clever. It's called the 3rd angles theorem. That's what I'll allow you to put in your proof instead of writing the whole theorem out. You're welcome. So you got the 3rd angles theorem. All right, kids, do we have all 3 pairs of sides? All 3 pairs of angles. So what do we know about the triangles? They must be congruent. Yep. So now you're going to write your first ever congruent statement correctly, because you just can't write triangle whatever congruent to triangle whatever. Remember what we said? Sides and angles must match up. All right, so I'll allow somebody to just take one triangle and name it any way you want. 12, take one of those triangles and name them any way you want. Okay, very unique. Yep, creative. Triangle ABC, congruent to. Now you got to make sure the sides and the angles match up. So you just can't call the second triangle anything you want. Make sure angle A matches up with its corresponding angle. B, C, line set, side AB matches up with its corresponding side. Seven, when they all match up, what's it look like? Triangle EDC. All right, I always make a quick glance myself. Let's see, A and E, good. B and D, good. Yep, AC, side AC should match up with EC. Perfect, I like it. And then my reason, how do I know they're congruent? If all corresponding, now, again, here we go, ready, stop. Still more whining from some of you. I have to write all of that. Are you kidding me? You just let me write third angles theorem, so there should be something, and yes, there is. You can now write, instead of writing all that, you can just tell me definition of congruent polygons. Or you can write the whole thing out if you want to try to impress somebody. Go right ahead. All good. One does not make you great. Yes, you're hungry for another one that you get to set up from scratch. All right, here we go. Let's start with the sides. I did not give you all three pairs of sides here. And also just to let you know, there's no such thing as the third sides theorem. Okay, because two pair are congruent, the other pair are. That doesn't work for sides, only for angles. So please do not use it for sides. What side am I missing from both triangles right now? 20 nothing, 14, and GN, a side they share. What do you know about GN and GN? They are congruent. Yes, indeed. Get used to that using them in the using this in a triangle proof. GN is congruent to GN in the other triangle, little thing we like to call reflexive property. Yep. All sides are done. And according to my givens, only one pair of angles, C and D, are taken care of. Need another pair. Need two more pair, actually. 29. It won't be until the next step. You have to tell me they are. Hey, take a look. I gave you that there are right angles here. That's why we said they were congruent right away. But now, did I give you the right angles? No, so you cannot tell me they are congruent until you tell me they are right angles. So we're going to have to go with angle CNG and angle DNG are right angles. Please tell me they are right angles before telling me they are congruent. And we have had this reason multiple times in the past, why two angles are right angles. I'll accept a couple different reasons. 5, got a reason for me? Yep, perpendicular lines form right angles. I've seen some of you write definition of perpendicular lines. That's fine too. Now you can tell me they're congruent after you tell me they're right angles. All right angles are congruent. Okay, there it's 2 out of 3. You still need to get me the third pair. The top pair. Do not add in words that are not there. How many times have I seen oh, it's getting bisected. Where is that word coming from? Where is that word coming from, bisector? No, it is not. Why are those final pair of angles congruent? 8. The old third angles theorem. Nice job. Angle CGN congruent to DGN. Third angles theorem. Do I have everything I need now? Sides and angles? All right. Now they're congruent. And good news, you don't even have to write your own statement. It's right there for you in the proof. Definition of congruent polygons. This is a lot of work just to prove them congruent, right? I got good news. You won't have to do that much starting tomorrow. But for tonight, yeah, you got to prove all 3 pairs of sides and all 3 pairs of angles. Anything on the proofs end before we hit up algebra to finish class? Anything? Okay, let's get algebra involved and then we'll call it a day. I have the wrong, there's no triangle ABC, sorry. Triangle RSV congruent to triangle. Okay, find X and Y. And I tell you the 2 triangles are congruent. My problem is, hey, I'm not really a visual person where I can turn this triangle and make sure all the sides and angles match up. I'm not really that visual. So if you're in that boat with me, you can use the congruent statement to see what sides match up. 15, your call first. You want to find X or Y? X. All right, here we go. So finding X first. X is an angle measurement at T, so I'd really like to find out what T corresponds with in the other triangle. So what does angle T correspond with in that other triangle? 29. T and what other angle correspond? R, whether you turn that or make sure they match up, T and R. Okay, but I also have a problem though. I have no idea what angle R is. Whatever degree measure R is, I know it'll be T, but I don't even have R. So anybody find a solution for me here? 9, how can I find angle R? Say that again? We're talking angles though. Angles, not sides, angles. So I'm looking at angle R right now. So 2y minus 1 has nothing to do with it because that's a side length. Yep, keep going. Yep. Minus, so I got 180 minus the 90 I'm already given and the 78 I'm already given. There we go. And that gives me 12 degrees left over. So that tells me X has to equal 12. Everyone good there? 12 degrees. And then how about, now we got to find y. So first thing I'm going to ask, what's RS correspond with in the other triangle? 3. What's RS correspond with? VT, yep. And what did I label as VT, Izzy? So I'm going to set 2y minus 1 equal to 24, because I could have set it equal to 24 and a half. I threw that up there just to confuse you. All right, but it does not correspond with ST. It corresponds with VT. And as you guys solve for y, 17, what do we end up with? 12 and a half. Got it. Everyone all right knowing how I knew where everything matched up, whether you visually turn the triangle or use the congruent statement? And then finally, just to make sure we're good to go, can you write your own congruent statement here for those two triangles? Before you do here, can we have some arguments? When are two polygons congruent? What have we found out today? When are two polygons congruent? All sides and all angles. I didn't mark H and R congruent though. So why are the triangles going to be, how are the triangles congruent if H and R aren't even congruent? Did I even need to mark them congruent? No, because of what? Third angles theorem. There you go. So you guys, one person right now, triangle so-and-so, congruent to triangle so-and-so, making sure the order matches up. The great part about this that I love, everyone could have all different answers in their own group and still all be right. Just as long as you match up the sides and angles correctly. So name that first triangle any way you want, and then work on the second one to make sure everything matches up. Seven. Hold on, Aaron. Before he goes, I'm going to write what he says down. Maybe different than yours, but that's okay. We all realize that. There's not one single answer here. Go ahead. So what was the other one? Sorry. Okay, just let me do a quick glance here. It's all right to get nervous. It's all right. D and Z, F and P, yep, H and R. Let's see, DH and ZR. Looks good. Okay. Everyone else all right? Okay, you only have a few problems there tonight. 2 of them are proofs. So the proofs, I did not, if you go to Aspen and look on the answer key, I did not put the proofs there because I want to see what you do tomorrow. Okay? Nice job.